are going for them. So request you to vote on the poll that has just been given to you. And based on feedback, I'd love to hear how we can improve the experience. If you think we are missing certain components, either in classroom or offline, we can see what we can do to facilitate learning. The goal of bootcamp obviously is not for us to graduate with a certificate. The goal of the bootcamp is learning. So if in some way we are not able to meet the requirements to facilitate your learning, let us know. We'll try our best to see how we can make that happen. Please vote on the poll if you haven't yet. And there is one more poll that I launched. Please vote on all the, actually three more, total of 3 questions. Please vote on all of them. This is just to help us warm up and also understand where we are, where others are in a sort of a big view. So there should be 3 polls that you see in total. Please vote on all of them. Okay, while you continue to vote, what we will do is maybe we can start with a quick recap of what we did last week. So last week we started with the part 2 of our bootcamp, which deals with traditional machine learning. And the first thing that we did was introduction to data science, where we tried to practice data science with some example data set and some sample code. So when we go into that classroom, what we noticed is there were sort of snippets of code that I had shared, which allowed you to essentially implement some basic exploratory data analysis. And we talked about how we can import comma-separated values into comma-separated values into a Python notebook, and how to import it, how to make it available as a pandas data frame. And then we did some very interesting analysis on the California housing data set, the toy data set that we had. And we talked about how we can do univariate analysis, which is to understand how an individual variable is behaving, the values in that under that attribute is behaving. And then we did bivariate or multivariate analysis, where we tried to compare or understand even visually how 2 different or multiple variables are interacting with each other. And I think we did this interesting example where we showed bivariate analysis of median house values and versus median income that was plotted on a sort of a latitude, longitude coordinate, essentially the California map that we see here. And we were able to distill some conclusions, right, based on some visual analysis. And that is one of the methods definitely that we can use to explain the data, because data visualization is perceived better. Images are perceived better than tables for most humans, right? So that's the goal. And then we finally did some what we call the correlation matrix. Correlation matrix helps us understand the correlation between 2 variables, and here 1 meaning 0 to 1 meaning positive, different varying degrees of positive correlation, and 0 to minus negative is negative correlation. And we saw examples where there is very good positive correlation and examples where there is negative correlation. And we talked about why that is, sort of in a general perception. And then we did a classroom exercise to split California into north and south, and then we basically repeated some of the exercises that we did in the classroom to basically redo the exploratory data analysis using those two data sets, and now comparing what differences we see, I believe. And I think we did classroom exercise number 2, but 3, 4, 5 were not done. But I had encouraged you to explore further. If you have explored further, and if you do have questions, please put them on the chat or raise your hand and we can talk through those. If there are no questions, we are going to close. And continue with the next thing, right? So I see that I'm going to end the poll for now, and we'll see how the conclusions look like. So essentially, what I see is in the overall aspects, it looks like there's good participation. It looks like so the overall bootcamp seems to be fairly balanced. There's a lot of good votes on good. Maybe not as many on great, which is fine. But I guess the interesting parts are going to start showing up. So I'm assuming you'll start liking it more because we learn how to train models and how to make useful predictions from those. And then the poll number 2 was with regard to practicing lessons. It looks like many of you are now able to do classroom take-home projects and also spend some time learning, which is great. And I see some people who have not been able to learn beyond what is in the bootcamp, which is also fine because this is a precursor to further learning beyond the bootcamp. And then the last one is willingness to interact in today's session. That looks very positive to me. A lot of votes on yes, a lot of votes, in fact, on even more votes on depends on the topic. So I'm hoping some of the topics that we discuss really comes as something that you can participate. This is not going to be, today's session is not going to be very technical, but from a perspective of programming, but from a perspective of practicing data science, I do believe honestly that today's session is central and sort of fundamental to being good data scientists or good machine learning practitioners. So with that, we'll get started with today's class. And what I would like to start with is, as you can see here on the schedule, I posted the classroom notebook for today's session. And if you were to open that notebook, you will see that it almost has no code. It is a lot of discussion points and a bunch of links. So we'll go through some of those links. And I want today to be a open-ended discussion, which means I want to see really good questions. I think last week, one question that is stuck in my mind is where somebody asked, why cannot we train a model that can have 100% accuracy, right? And I think I gave 2 examples of when a model might achieve 100% accuracy. One is when the problem is too trivial and obvious that the machine learning model is just able to nail it consistently. And then the other case is where your model is memoizing, which means since it is a trivial problem or you just have very minimal variance in the data, it's able to basically memorize the data set, right? And then there are other issues like implementing training with the wrong criteria, not having clear training, testing data set or validation data set splits. All of those things, we'll talk about it. And end of the day, machine learning or data science is an iterative practice, which means at no point can you say that your work has conclusively completed. You always will have opportunities to continue improving on the models. So when we look at the ethics of data science, I put a simple thing about ethics, right? So ethics, I'm sure most of us take classes in philosophy, psychology, and ethics, pretty much regardless of what domain we are in. And that is fundamental because when we go practice our domains, we are responsible for making sure that we are doing the right things, right? For example, doctors, they take an oath, right? The Hippocratic oath, which basically is sort of a symbolical way to convey to them that they have to respect certain ethics of their profession, which is providing healthcare and treatment to patients. Right, that is one of the ways. And similarly, engineers obviously don't have such a formal ritual of taking an oath, but fundamentally, when we go practice engineering in general, we've all taken classes either in undergraduate programs or in graduate school, where we have learned about the importance of ethics and where the pitfalls of not following ethical principles are. So from that perspective, I want to hear if there are any other definitions of ethics that the classroom wants to make. So please unmute yourselves, and if you have a unique definition, I would like to hear it. What does ethics mean to you personally? It does not have to be from a dictionary example, right? I want to hear what it means to you personally. Can we get some volunteers?
I think ethics could be like the way to make a good practical decision.
Okay, that's one of the good definitions. Okay, and so Swapnil says ethics is one way to or a framework to make good decisions, right? Okay, well, what other things come to your mind, Aban, here in the classroom? Morals and morality, right? He's talking about two things: morals and morality, and those are all. Ethics is in fact called moral science or moral principles also. So that's a good one. Anyone else? So let's move. I guess there are more opportunities for us to have this conversation. Like I said in the start of the classroom, today is the value of today's class will be delivered if you can interact and share your opinions. I think that is where we'll learn a lot today. And fundamentally, when we talk about ethics, right, the understanding that we should have is ethical values, principles, and standards. They are a response to some new challenges, innovations, and societal values that evolve, which means ethics that were held high 50 years ago may not be the same in today's society, which means ethics is going to continue to evolve as various aspects of human life changes, right? Like technology, society, economics, culture, religion, and lot of things will come into play, right? But we are not here to talk about the philosophy of why we should practice ethics, but here we will try to focus on how to understand ethics in the context of data science and machine learning, with some examples, and what are the ways in which we can practice ethics, because ethics is can in some perspectives, ethics can be talked about as philosophy, but in the context of data science and machine learning, I can walk us through some examples where it has to be put into practice. If not, there could be potential challenges, right? It could be in a lot of different ways, right? And we'll look at what that means. So when we mean we understand ethics, right? It is tough to make a judgment to say that when we do something, when a human does something, it is really tough for us to conclude that it is absolutely ethical, right? Because who am I, or who are we to judge that we are the flag bearers of morality? But that should not stop us from trying to practice ethics. And the second concept is from a perspective of data science and machine learning, it is a community of practice. As you know, we try to do things, and we have a ability to influence decisions. So like we discussed, data science is the is fundamentally today driving decision science, which means the art of making decisions, how to make decisions, how to make decisions that are helpful, and in the context of the broader society. So when we do that, I think the practice of ethics now becomes much more clearer, which means data science and machine learning has the ability to really impact the society. And that's the reason why people who practice it need to think about it every time they write a line of code, every time they change the data set, every time they change something inside the data set, how they clean it, how they manipulate it, and so on. So having understanding of that fundamental philosophy is good for us to get started. So now the question comes to my mind, right? I want to ask, one second. So one thing that I see is I want to ask this question out loud, which is the practice of ethics in data science and ML a choice, right? So I want to understand from your perspective, is it a choice? If not, if yes, why? If not, why?
I believe it's a choice because you have a choice to choose whether you want to collect data in like a correct and unbiased way or in like a skewed way that might hurt a group of people or be morally incorrect.
Correct. So what I think Alex is saying is it is a choice, which means at the center of the decision of whether you practice ethics is you, right? How you think. So then it fundamentally becomes important for you to understand what will be done based on the decision that my work is going to drive, right? And when you think about it, you need to think about its impact on your ecology, on people, on society, on others, including yourself, right? Your own people, your own family, friends, relatives. And when you do, when you make that your central theme, which is to think about the well-being of yourself, your own people, and also people around you in the society, then the choice of whether to practice or not becomes very, very clear. Which means fundamentally we have to practice ethics, because if we don't, the outcomes can be felt not just by others but our own selves, right? And there are examples where people have built products without ethics, without consideration for ethics, and it has caused them hurt. Really interesting really interesting case studies where they have shown people without thinking through ethics did some decisions and it actually hurt them, right? So those sort of things continue to recur in the society, which tells this is a fundamental thing that we have to take control of, which is we have to figure out the choice. And what are the outcomes of practicing ethics in data science and machine learning? I've listed a few outcomes, right? Like how to measure, what to focus on. So I'd like to open this discussion to talk a little bit about each of those, right? And this is going to be, again, interaction. I'm in no way a legal authority or a scholarly authority on ethics in data science and machine learning. So it is a opportunity for me to learn about unique perspectives that may come in the classroom. So the first thing is reducing risks or adverse outcomes. What does this mean to you? Like what does reducing risk mean? What comes to your mind? What is the definition? How would you define it?
It's like to lower any chance to like get harmed from something.
Okay. And what about adverse outcomes? What does that mean? Sure.
One idea or option is maybe let's say if the data set is not well balanced, then you might be over indexing or under indexing on certain aspects, which tends to give you results which are skewed. And then if you believe that those results are true, then you could potentially go down a wrong path of executing something.
Correct. So that's the reason why we had to focus on reducing the risk of making the wrong decision, right? Or adverse outcomes. In this way, when you think about the outcome, you now can figure out how to make sure that you don't get to that adverse outcome, right? So that's one of the ways in which we can practice ethics in machine learning and data science, by understanding the outcomes of what happens by our work. And what is legal compliance? Why am I talking about legal compliance, I guess?
Well, several countries and states in the United States are enacting acts related to data protection and AI. One such example is the EU AI Act, which defines good practices, or what can be done and what cannot be done when developing an AI application. So if an AI application we develop is not in compliance with those laws, then potentially the person or the company could be held legally,
liable,
responsible, liable. Yes, thank you.
Correct. So that is a very good example, which means we can make a product and ignore the ethics of it. But if it violates a law, right, then we may be subject to prosecution, we may be subject to paying liability or compensation, and that can potentially damage not just reputation, but also the business itself, right, that we are trying to build. So I think that's, again, fundamental, which is one of the outcomes of practicing ethics is to make sure that we are legally compliant, right, for one or more geographies in which we intend to sell the product, right? So that is one of the other challenges that we have to deal with. The next one is the safety aspect. Give me an example of where safety becomes pertinent in the context of data science and machine learning. What comes to your mind when you think about safety?
Automated driving?
Yes, absolutely. That's, I think, the biggest question that we have today, right? Has autonomous driving really reduced injuries or fatalities? And why has it not, right? Like the quick answer to the first question is it has not really helped. But then the other aspect is, why has it not helped? Which means there are still gaps in how the data sets are, what data sets are available, and also what control we are able to give these autonomous systems to make a decision on a model that is not fully representative of the actual data distribution in the real world, right? And then I see something on the chat, right? Mohsin is saying cybersecurity in the car, so no hacking, right? So that could be one of the challenges also, right? Which is if your cybersecurity solution is based on some data, or it is collecting some data, right, in the context of a car or things like that, that could also be one of the facets, right? I'm not talking about safety in a general perspective, but safety or risks to safety arising from the practice of data science and machine learning, which means whenever we are training models or algorithms based on some data, the decisions that come out of these models, if they have implications on safety, that is what we need to focus on. Which means if we are in a company where we are trying to build a car that will basically help people go from point A to point B, then we will be responsible for their safety, and we cannot say, oh, I trained a model, you paid for it, but I cannot be held accountable for your safety, right? We cannot do that. Like material, people, property, all of that has to be, the safety of all of those things have to be paid attention to. And finally, what comes to your mind today when I say privacy and security? Again, in the context of data science and machine learning.
Maybe by collecting data in a way that it can't be traced back to the individual. Like you wouldn't want to collect somebody's social security number, like their address, unless you really need it. So
correct. So that's a really good example, Alex, which is it's typically called PII, which is personally identifiable information. So a lot of times we collect PII data. In fact, to sign up to this course, I asked you for some PII data, right? And technically, I now have a small data set, maybe with 50 rows of information, but it still has some sensitive data, right? It has a it tells me where you work or where you study, what is your full name, what is your email ID or whatever, right? And now the pertinent focus for me is to make sure that that data remains private and only goes to people who absolutely need it to make a decision, right? And in this case, not many people need it. So, and that's the reason why I don't go post it out to somebody, or I don't sell it to somebody to send you emails to solicit buying their product, XYZ, right? So whenever we deal with data that we collect from that we collect on our own, or we sort of collect through forms and things like that, I think as practitioners of data science and machine learning, we need to think about it. And there's the other aspect, which is somebody says, hey, I have this data set and it really has very interesting data, right? And now if they are saying, okay, I'll give it to you for free, right? And there are no holds, no obligations to give me money or something, right? But it still is, there is still an ethical question there, which means even if somebody volunteered a data set, are you allowed to use it? Is it legal? Is it ethical to use it, right? So that is also another aspect that we have to think about, which is even if the data set is available for free or you somehow found it, you still have to think about whether it is legal and ethical to use the data set. So that's the other aspect of privacy. And then security is the other aspect, which is once you do things, you build a model, you start training your data science, you start practicing data science, you may be showcasing a lot of reporting and you may be generating data or sort of summaries of that data. So you still have to make sure you know that those summaries or those communications don't leak your data indirectly. And that's the security aspect, right? Which means to protect all the systems where you're practicing. And then finally, social harmony, right? Like there are outcomes where if you make a wrong prediction and somebody uses that to do some decision, and that has an impact on society, and it could cause unrest and disharmony in the society, right? So we have to be careful where we make very big conclusions without really thoroughly understanding. So that's one of the reasons why I mentioned at the very start that data scientists may not be domain experts. So when you do, let's say, some experiment and it gives you some output, it is always advisable, right, to make sure that you're always working with a domain expert who will help you understand what could be the pitfalls in the decision or the inference, and communicate it through the means that is more appropriate, rather than just saying, okay, now the model spit up this output and I'm going to communicate it to the world, right? And that's not the right way to practice data science and machine learning for this reason. And finally, transparency, trust, and fairness, right? Three big words. Transparency is where fundamentally you tell where did you get this data from, what is the model that you're using, and how do you think that the process that you did for data engineering, which is how did you clean the data, how did you filter the data, how did you make decisions that manipulated the data further, how did you normalize the data? All of these things have to be described. Whenever you say publish a paper based on a data set, you have to disclose all these things. And that's basically one of the fundamentals for showcasing transparency. And then the other aspect is trust, right? When you showcase that you are building products that are ethical, you can now build trust with your customers. And then that helps you improve the opportunity to service more customers and so on. And then there's fairness, which means, in other words, it can also be like bias, right? Which means, is your data set fair? And if the data set is not fair based on your determination, then is the model that can be generated using that unfair or biased data set, is that going to be useful, right? It is obviously not going to be useful. So we had to be careful when we do different steps of data science and machine learning. And we'll walk through those examples a little bit today. But in the take-home assignment that I will share tomorrow, you will actually work with some examples where you will do exploratory data analysis to actually figure out how to practice some of these outcomes within the context of the ethics in data science and machine learning. What is explainability? Can somebody volunteer? What does that mean to you? Do you know what explainability is?
I can try. There's a lot of manipulation that happens on a data set, right? We talk about billions of parameters and several nodes as the data gets transformed before you get the output. So it's the ability to explain how you got from the original data set to a result, like what happened in between, so that you're able to fix things in case the result is, let's say, it violates any principle, or if it's incorrect, or any of the above that we just discussed.
Correct. So to summarize what Harsha said is explainability is when you say train a model using a data set, and now you're sending it actual real world inputs and you're trying to get predictions. Can you explain how the model is making those decisions? Which means your model should be understood by you. You cannot just train a model just because it was trainable, but you should know what is the reason it is making a certain kind of a decision, right? And we'll come to that. We'll actually walk through many of those examples, especially in the take home, but also in the next session, which is where we start training machine learning algorithms, right? Like regression or classification, logistic regression sort of algorithms. What is accountability, right? Like accountability is where you commit to deliver a model or data set or data science predictions, which are based on the fundamental principle that you're not trying to do that in the hiding. You always are willing to put your name against it. You're willing to put your reputation against it. And that in a way can be a compelling argument to say we had to practice data science without having to cause damage to our reputation or property or finances and so on, right? So that's one. And then what is prevention of abuse in this context? Have you heard?
It basically means that the data is not being allowed to use for the wrong purposes.
Correct. So that is one example, right? Which is if you share a data set that you created, you explicitly make sure that people don't use it for the wrong purpose. And there are multiple ways to think about it. If it is public data, you can probably remove the PII, you can remove the personal identification information, you can make it abstract enough and make it available. But in some cases, data sets have to have PII data. So in those cases, you will rely more on securing the data, right? Which means you maintain the privacy, safety, and security of the data set itself, which means you'll not share that data set out into the public. And from the context of models, have you heard of this prevention of abuse lately? How do you prevent abuse? Have you heard of how LLMs or large language models can be subject to abuse?
Maybe by using them to do your homework or like write essays or academic papers that might affect others in a way.
Yeah, that is correct. So that is one example, which is you want to use it, but then you are using it in a way where it goes against the ethics that you align to as a student, right? Which means when somebody gives you a assignment, they're expecting you to use it to learn and not to use some other tool like ChatGPT or something to solve it and then say claim the credit for doing it. And that's one example. And for
Another
please.
example could be deepfakes.
Deepfakes, exactly. So people can generate images, they can generate audio, they can generate video today, but the ethics compels the creators of those products to think about the implications of releasing a image generation model or a speech generation model or a text generation model, right? You don't want to let bad elements in the society abuse those tools to do things that could be harmful to specific people, targeted people, or it could also be abused to larger sections of the society, right? By creating fake news, fake videos, all those things that never happened, right? And it's become more and more tough in the modern world, especially in the context of AI, to really distinguish what really occurred and what did not, because there are bad elements who are already able to practice these by going through the wrong means, right? It's tough to stop them without the legal issues involved. But as data scientists, as machine learning engineers, we have to think about the implications before we go develop something, right?
Yeah.
I think recently there was a please.
So yeah, I also heard about like AIs being used, like teachers use like AIs to check their students' homework for AI. So I've heard like stories about how the AI was used to check student college essays, and basically the essays were wrongly flagged as being written by AI when the student had actually written it by him or herself. So
correct. So this is also the other side, which is AI to detect use of AI. That itself is not a solid science. That is correct, Athar, which means there's always a certain degree of abuse that can be done, even with the well-intentioned individual. If they use the tool without the knowledge, and now they're trying to make a decision on somebody's college application or life credit card application, that could be bad, right? So that's a really good example of saying abuse can happen from bad elements who know how to abuse, but abuse can also happen if somehow somebody accidentally uses your tool. So which means when you also create a model or send a data set, you have to tell people explicitly, this is not to be used for this. Do not make decisions based on this data set. This is just a representation, right? So you have to convey those things and, if possible, put some limits on what they can do with the data set, licensing, XYZ, right? So all those things come into play. And I think the other example that comes to my mind is very, very commonly talked is credit card limit allocation, right? Or credit card approvals. And this has historically been a hot topic because there have been very big examples of bias against gender, bias against ethnicity, bias against some zip code. So there are different kinds of numerical data or nominal data that we discussed like earlier, right? Qualitative and quantitative data. And if the model is treating those as just variables and attributes and training something without really understanding the dependency or attributes in a clear way, you can end up with a model that can make decisions for you, that can now try to project that bias onto society by becoming part of the automated decision systems, right? So whenever you do something that does a decision, it's always important for you to think about the implications of the decision on people, lives, property, XYZ, before you tip it out as saying that's ready to roll, right? So a really good engagement so far. So one really good, we'll go through some of these things today, right? So Dion, right? Dion is this checklist, right? So when I go to that link that I sent you, it is an ethics checklist for data scientists. I found this tool to be very interesting because what it does is you can do pip install Dion. It's like another Python package, so you can actually install it in your notebook. But then what you can actually see is when you install it, you can actually go through the data science ethics checklist. And it has a standard checklist that they've committed to that package. So if you install it, you will be able to see it within the context of your project. And the focus of creating this as a pip package is to make sure when you do some data science, you go through this checklist and explicitly say, make sure that you are not violating one of the recommended ways of practicing ethics, right? So good examples here, right? Like I think we walked about some of it, which is data collection. Are you, have you really explicitly asked for consent from people who are volunteering the data, right? You volunteered your data to sign up for the bootcamp only for signing up for the bootcamp. If somebody tries to sell you something else, that is a violation of your consent, right? So I think those sort of things we have to understand, and we had to apply to each step of our data science journey. And then collection bias, right? If I'm going and offering, let's say, the quiz in the classroom only to, let's say, participants from a certain gender or a certain ethnicity, and then making conclusions, I'm already burning a bias, because I'm now getting biased data by narrowing down the collection to specific individuals who may already be part of one homogeneous group, right? And that's collection bias. And then limit PII exposure. This also came during our discussion, which is personally identifiable information. We have to make sure we can anonymize those information as much as possible so that real identities are not lost when security breaches happen. And that is very often happening more often these days, because right from your bank to your grocery chain, to your favorite restaurant, to your favorite credit card agency. I'm just kidding, there are no favorite credit card agencies, but all these people are collecting personal identifying information, and very often we get notifications saying your personal data was compromised and we are now giving you credit card protection or credit rating protection, XYZ, right? And all of those are really ugly examples of what happens when somebody does not secure the data, right? And that's also going to be discussed here in data storage. And then there's the downstream bias mitigation, which means you can train a model or you can collect data, but then have you considered ways how you will test for it so that it does not generate biased outcomes, right? And those are things where some protected classes, if you violate, you're not only violating the ethics, but you may be also violating the legal regulations around it. So you cannot be making, you cannot be collecting data that where you're now burning bias into it. That has to be avoided. And then the data storage, right? So data security. Once you get somebody's data, collect data, you have to make sure that you really know how to protect it. And right to be forgotten. That's also one of the things that has come specifically in the context of EU, right? There are GDPR and other laws which say if you don't want to be listed by Google on Google search, you can get your name out. And those sort of things will continue to propagate across the society, across the world. And very often there may be withdrawal of consent from people, from organizations, and so on. So we have to understand that we have to make sure we remove that data from our data set. And then data retention plan, right? So if you make a data set that today, and 5 years down the lane, if that data does not become useful because it is stale and meaningless, you have to come up with some way to figure out what is the retention plan, so that you don't just make decisions on old data, right? You have to make sure you always make decisions with data that is relevant and new. And then the analysis, right, which is missing perspectives, blind spots, right? You don't want to sit and make analysis as a data scientist. Here they say you have to do it with relevant stakeholders or people with domain experts or subject matter experts, right? And you have to bring those perspectives to understand the outcomes of what you're doing in terms of analysis. And that is very well done if you can engage with these stakeholders even before you write your first line of code, right? And you have to understand their perspective before you come up with a hypothesis for what you are intending to do. And then there's the aspect of data set bias, right? Like data set bias is the imbalance in classes, which means you cannot collect minimal data and then try to generalize it for large populations of society, whatever the classes of objects are. And then there can be stereotypes that you are perpetuating. If I always take all my feedback from Folsom Lake College and try to generalize it for all campuses across the US, it's probably going to be bad, because they don't necessarily experience the same conditions, whether it is society, economics, or temperature, whatever, right? There are so many factors that play into whether students feel happy to come to a college, right? There could be severe winter in one college and not in Folsom Lake. So all those things can come into play when making decisions, so you have to be careful. There's confirmation bias, which means you try to collect data that confirms a belief that you have without really trying to truly test the hypothesis, which means you're defeating the scientific way of questioning things by navigating to a data that will, or analysis that will give you the conclusions that you want, right? And that's one of the pitfalls of wrongly applying science or statistics. Then there's imbalanced classes that we discussed, and then omitted confounding variables, which means if there are variables that are dependent on each other and they are omitted, then that could also cause challenges to bias, or in some cases, having them could cause bias. And then there's the honest representation, which means whenever you plot visualizations, summary statistics, are you truly representing the underlying data, or did you falsely remove some data just to make your visualization look cool? That's also something that you have to focus on. That's unethical. And then there's privacy, right? Whenever PI data is available, make sure that whoever has access to the analytics tools, they are authorized and they know how to practice security and safety and privacy. Then there's auditability, which means anytime you do some analysis, there has to be some auditability or explainability to how you arrived at the conclusion. And in fact, our notebook is a great example, which means whenever you do something in the Jupyter notebook or you write a Python script, you are now documenting the different steps in which you manipulated the data and you trained the model. And that itself is one of the ways to say that your data science work is auditable. You don't want to ship all your data to some non-transparent, like opaque function, and nobody knows what that function does. That is illegal or unethical, right? If you think about it. And then there's the modeling aspect that I'll briefly touch upon, but we will talk more about it in the context of machine learning in the future sessions. You can have challenges in modeling, right? Which means if you take a model and there are, in some ways, you can introduce bias in the way you model. Even if the data set is not biased, you can use bad techniques or poor techniques where your model now figures out some bias and it tries to perpetuate that stereotype or bias. And you have to be aware of it, right? And how to detect it. All those things are important. Explainability, that is important. And then metrics, right? Which means how are you optimizing the model fine-tuning process? What are the metrics in which you are saying this model is good enough to roll out and become part of the real-world decision science? Those sort of things, metrics have to be clearly understood. What are the effects of those? And then the communication, right? Whenever there are shortcomings or limitations, have you sufficiently paid attention to communicating those to stakeholders? That is also one aspect. We'll touch upon a lot of those in the take-home, which means in the take-home, I'm going to give you a data set that clearly has some bias, but you will figure out what that bias is, and your focus on the take-home is to comment how you found it, right? And that explainability will come by the code that you write. And then finally, you'll write some conclusion where you are going to communicate the limitations and why you think this data set is good or bad for making a certain kind of decision, right? So that's going to be the premise of the take home that we will send you tomorrow. And then finally, the deployment, right? Like whenever you send something out, a model out, you have to monitor it. You cannot ship a model and say, you got your model, I'm good, right? You cannot do that. Like, for example, if there's a autonomous driving a maker like Tesla, for example, if they continuously monitor and evaluate how their model is performing on the field, right? And that gives them additional data to figure out how to continue to fix problems in their models, in their systems, and improve. So that sort of monitoring and evaluation is also part of what you should design when you train a model and ship it. And then there is redress, right? Which means if something does happen, what is the mechanism in which you will help address the challenges, or what is the thing that you'll do, which is, are you going to recall? Are you going to disable that model? Are you going to fix that model? What are the ways in which you can address the harm that may happen unintentionally or intentionally? And then there's a rollback, which means you send something into production, but now it has bugs in the model. There are bugs in the data sets. Then how do you roll back that item and go back to a version where the model was still believable or trustable, right? And then the unintended use, right, which means you just have to prevent people from abusing your system, right? And those are the different kinds of things that they recommend. And of course, in this package, they say you can also write your own checklist. So one of the things that we'll do out of in the take home, and in fact even in the final project, is you will install this Dion, and you will make a comment on those as part of your project, which means it will help you become a more well-rounded data scientist or machine learning engineer by understanding the implication of what you're trying to help design. And there are some really good resources on ethics. I encourage highly that you look into some of these for sure. I think one example I wanted to highlight was was this one, which is the document from Google, right? Developers.google.com, which talks about fairness or types of bias, right? And these are all different kinds of bias. I would like you to go through the basic definition of what this is. And in fact, what they do is I think they try to give an example also, right? So you can basically look at an example in which you may have a sampling bias here, right, in this case. So please, I really recommend that you look through this. And some of the terminology that they use here is industry standard. So I may ask a question about certain kind of bias that the data set that we are going to provide you might have, and you will have to identify how what it means and how to detect it, come up with ways to detect it, and so on. So any questions before we proceed? Or any comments from your end?
I think Krishna had a question in the chat.
Oh, okay, let me address that. How do AI engines prove themselves from biases introduced by users? So Krishna, can you give me a little bit of context? What do you mean by AI engines?
Hi. So basically, I was asking, for example, chatbots or AI chat engines. How do they prove? I mean, they are still learning, right? While they have conversations or chats with other users. If there are social biases introduced by users, or any ideas that are brought in by users, how do they prove themselves?
Okay, yeah, okay, now I understand it. So in the context of this example, right? So there are in training, there are two types of training. One is what is called offline training, which is very, very typical, which means you train a model in a lab or in a development environment, and only after you validate it, you allow it to go into the world. And the other is the online training, where you get some data from somebody in real time, you're trying to train the model and you update it. So typically, the things that chatbots are trying to do is to fight this issue of bias is to only do offline training. When you do online training, you don't know what people are giving. So it is very tough to make a decision whether to use the data point to train further or not. So the typical recommended approach here would be to train offline, where a real person will, or a team of people will come and look at whether that data is acceptable, standard, based on ethics, all the other considerations that they have, right? So that is one way. And the other way is you try to source data based on a very clear goal that you have, right? So for example, if you are building a chatbot that will help people in this classroom learn about machine learning, you should put in practice certain mechanisms to prevent people from asking it questions that are harmful or unrelated to even machine learning, right? So those sort of, there are some heuristic approaches there that are implemented today by leading chatbots like ChatGPT, where they use a combination of offline learning where the data is vetted by experts, and then the other aspect is they have some heuristic mechanisms where a certain keyword or a certain combination of words are automatically flagged as harmful, right? So basically, you cannot go to ChatGPT and ask it, how do I build a harmful product in using homemade chemicals, right? So you cannot just ask it that question. It just says this is against the user acceptance criteria, and it's not going to answer it. So all those things have to be built into the chatbot, and which means there will be a privacy, security, or model usage team within all these companies that are developing these customer-facing products, and they are the ones who are determining how do we prevent people from abusing it. Does that help answer some part of the question?
Yeah, it does. Thank you.
Okay. Any other questions before we go further? Or have you come, maybe another question I wanted to ask is, have you come across instances where you using a product that was powered by AI, where you found that there was bias or security or privacy issue? Any examples that you can think of?
Yeah, I mean, there was that Microsoft engine before ChatGPT, right? That almost like within 24 hours, it started, using certain social biases that were not acceptable, and then they had to take it offline, right?
Correct. Yeah, I think that's a very good example. So just to give a context to others, Microsoft had launched a chatbot similar to ChatGPT before ChatGPT showed up. I think ChatGPT 3 showed up. And basically what it did was, I think it was interacting with people over Twitter interface. And quickly they realized that since they had tuned it to do online learning or real-time learning, people, either for bad intentions or for fun, they started breaking into the model, which means they started forcing bias into the model. And that quickly became a very abusive model. It started showing abuse towards different kinds of protected categories. And then finally, Microsoft realized 24 hours later that it was a huge liability and they had to take it down, right? So that tells you that online learning is very tricky, and it's not easy, even for the best company, one of the best companies out there, right? So that's a really good example. But personally, I'm trying to understand if personally you have identified any examples where you thought a system that you use in your personal life had a bad or a undesired outcome while you were using it.
Definitely there are, fringe issues where any kind of AI system that you use, you can make mistakes, right? I mean, you need to kind of vet whatever it does, whether you make it generate an image, or whether you're trying to use it to make some code or whatever it is. You can make mistakes, but then you need to kind of vet whatever it does. That's one thing. But apart from that, I have not come across like social bias or anything like that.
Yeah. I think those are much harder to detect typically, especially with just chatbots. But they may be more in those protected data sets that may be making life-changing decisions, like whether to approve your home loan or your credit approval, credit rating, scoring, and all of that, right? So those sort of things exist. It's just that we are not aware of it. And I think one of the links here shows some examples of real-world examples where it caused millions of dollars in loss or reputation damage or issues where they lost customers due to that, right? So please go through the reading list for such examples. I think one interesting example that comes to my own experience is I was driving in the autonomous mode, and then every time it saw sort of a park gate, it would basically swerve the car, right? And that happened after a model update. That behavior never existed before, but it so happened on a day last summer I got that update. I said, okay, the model, it's a new model, I'm assuming it's going to be better, and then suddenly it started showing this behavior that did not exist before, which means something happened in the training process where they had additional data, or they changed something with regard to how they trained the model, and it actually burned some bias to make a bad decision, right? But potentially it could have led to really bad consequences. If I was driving at very high speeds, and if it tried to swerve, it could have resulted in an accident, right? And loss of property, life damage, whatever it is. So those sort of examples do exist. I think that tells you that the job of a data scientist and machine learning engineer is never done. You cannot really test how good your model is, even with 1 million test cases, even with millions of miles of driving. And that itself is a huge challenge, right? And itself is a focus of research, which is how do you improve the performance of these probabilistic predictions without being able to test for every corner test case. How do you figure out how to prevent that from happening, right? Which means there has to be mechanisms at certain point where the model itself has to say, I may be wrong, or give a certain confidence level at how it makes the prediction. And if it is not confident, it should just say, hey, I'm not sure what this is, and I don't want to swerve, right? Because I know you're driving at 50 and I don't think there's a school gate in front of you, so it's highly unlikely. And it has to use other mechanisms to either defeat that wrong decision that it has made, or it has to say to a human user or expert to say, I'm not clear, let me give you the control to make this decision, right? And
I have
both,
a different
Yeah.
context though.
yeah,
I work a lot with FPGAs,
okay,
and so FPGA synthesis is you actually make an RTL and you have to realize it as a real circuit, right?
Mhm.
FPGA would need to synthesize it onto a hardware.
Mhm.
So if you use a high-level language or a high-level construct,
Mhm.
it is hard to get exactly what you want. So there are, for example, if you use a for loop or high-level constructs in
Mhm.
FPGA synthesis,
Mhm.
it might result in a hardware circuit that is way more number of levels of logic than
Mhm.
you can meet timing on, right?
Correct.
So
So basically, you're talking about what I think Krishna is talking about. I'm assuming most people don't know what an FPGA is, but FPGA is a reprogrammable hardware, right? Which means you get some transistors, but then they don't have a specific function until you define it using a high-level programming language. That is what he is describing. So when you describe it in a high-level programming language, at the end of the day, it has to be converted into a low-level representation, which means there's an optimization problem involved, right? Which means there's no easy way to determine what is the ideal solution. And in fact, that is actually very relevant to data science and machine learning, because end of the day, even if you have the same data set and I put 50 of you and I say, go ahead and train a model, I tell you what model to train, I give you the same data set, I don't think any of you will have the same exact model, and there will always be variations in how you make decisions, right? So that is exactly what I think you're trying to tell, right, Krishna?
yeah, so the point is that only you know the application that you're working on. Though the synthesis tools have come far compared to what they were 10 years ago, still you know your application and you can tailor it better than a tool. You use the tool, but then you have to constrain it
Correct.
properly to get what you
Correct.
want.
So what he's saying is, do not trust an autonomous system or an optimization system and say whatever outcome you give, I'm going to implement it. But instead have some metrics by which you can measure the performance, right? is it generating only within a boundary of logic layers, or within a boundary of how much memory it demands, or power, or whatever criteria, right? And similarly for an AI model, there are equivalents to that, right? Like accuracy is one, precision, recall, right? F1 score. So all of those things we'll discuss in the next session. But essentially what he's saying is, do not assume that your model is good just because you trained a model and then you tested it on 5 images and it said, yes, I see a dog in the image. Don't do that. Try to do statistical testing, which means test data set has to be big enough for you to conclusively say that averaged over millions of decisions in the test data set, you believe that there's a fair degree of fairness, and you should be able to show that through these metrics, right? And those performance metrics or accuracy metrics are critical for how you communicate the usefulness of a model. In fact, even for data sets or models, you may have heard of benchmarks, right? Which means if you go pick any AI model today, the publishers of the model will tell you what is the accuracy that they were, the best accuracy they were able to achieve, and how did they achieve that accuracy. And it tells you the way or optimization techniques that they used to train that model. So I think that is a very important thing to keep in mind, which means even if you have the same data set, same model architecture, or same algorithm for the machine learning model, the outcomes that are generated still can vary, which still means individually you have to test the output of each model against a held out data set called a test data set, and then make a decision whether to move forward with deployment or to go back to figure out why it is not behaving in the right ways, right? Based on those metrics. Any other topics that come to your mind in terms of what we have already learned, right? Like we have already learned a fair degree of at least the intro to data science. Did you see how the data set that we used last week may be wrongly used to make wrong decisions, or abused to make wrong decisions? Can you think of any examples? So the data set that we used last week was basically used to predict house pricing based on certain criteria, right? Is it possible to make a wrong decision based on such a data set? Can you think of examples where you can make a wrong decision or a wrong prediction, and what would be the consequence of that?
Wait, can you repeat that?
So last week we used the data set for the California housing prices, right? Where there were a lot of attributes, and finally there was a way to predict what is the typical price for a home in that region, or for different factors that were input, right? So can such a data set also be misused or abused? Yeah, using mean instead of median, right? Like Krishna, I think he pointed out, I think we discussed about it. So if we pay attention to the wrong metrics, even during exploratory data analysis, we may be using outliers to train the model, and maybe that is required, maybe that is not. So we have to make a decision whether to train with all the data set that was given to you, or you have to now clean the data set to make sure that there are no imbalances or outliers, things like that, right? And if you don't do that through the exploratory analysis, it is going to be much harder to do it by just testing the model and looking at the metrics. So even for training a model, one should always see whether the data set is clean. If it is not, they need to start from the first step, which is cleaning the data and making sure that you're not trying to build biases, confirmation biases into the data set. And the other way is typically is you're not the expert in understanding the data. So maybe you go get the data that is already cleaned, and there's a very clear description of how it was cleaned, and you can now trust it, right? So that's one way. Yeah, I think Rohan gives another example, which means if you now go try to predict that a house is always expensive in a certain area, it could still be cheaper, right? Like there are no variables that tell me if the house was constructed with wood or concrete, or if they used marble or vinyl or whatever, right? Like materials. So it's very tough to use that data set to make conclusive decisions. You can probably get in the vicinity of what the decision looks like, but typically to make a decision on whether the price of a home is appropriate, you have to look at far more variables, and sometimes quantitative, sometimes qualitative, which means you cannot go buy a house by looking at whether it fit in a regression model. You always have to go maybe physically feel the surfaces around the house, look for inspection damages, things that may not be part of the data set. So that's why whenever we go purchase a home, we don't go by Zillow's recommendation, because Zillow is just making decision or recommending the estimated price range based on their generalized model, which may not be true depending on other factors, on how well it was taken care, or how it was built, what materials were used, what quality of materials were used, and so on. So that's why what I'm saying is a lot of people assume by default that AI models will automate decision science. But what we have learned through really bad examples or experiences is that decision science is still complicated, and there has to be a human factor in it to prevent bad outcomes. So which means you still try to build AI models, try to still keep them clean and representative, but at the end of the day, to make a decision, you still have to rely on some human expert, human intuition, and so on. So I think with that, I want to sort of conclude today's session by showing, like pointing you to one data set, which is credit card approval prediction, right? So this is a data set that is available on Kaggle. So you can create a free account on Kaggle, and you should be able to download the data set. And our assignment, take-home assignment, is going to be based on this data set, right? I will post the assignment tomorrow, but you should be able to open that link and understand what the data looks like or what it means, right? It's again tabular data. We are still working with traditional machine learning. So the focus of the take-home will be to use this data set to figure out how to identify biases or identify issues in the data set. What are the approaches we can take to clean it? And what are the limitations of decisions we can make with that data set, right? Because we know that it has certain bias into it, and we had to basically do all these things by writing some Python code, using data science tools like pandas, visualizations, and the outcome of the take home is basically you will deepen your understanding of data science tools in Python's context, and then at the same time you'll learn different aspects of how to practice ethics at each step of the data science process. Any questions so far? I know today was a lot of talking, less of code, but I do believe that this is a topic where we have to bring our human perspective, because end of the day, ethics is based on moral principles, as I think Aban pointed, and moral principles are defined by humans, by the society, by the human society, right? So we have to bring that human factor to this discussion regardless. Yes, Swapnil.
I'm not sure if this was addressed before, but is the take home for the first data science class done yet?
So what I decided was to combine the practice of data science along with ethics, right? Which means you look at the data, you have to learn how to distill data or clean it and so on. So the data set that I pointed is not clean. So there are some issues with it. I'm not going to say don't look at the comments around the data set on this link. Please do go through that. I'm okay for you to learn it, but I think at the same time, I want you to figure out how to clean it using some of the tools that we discussed last week, or learn new things on how to filter data, how to clean it based on certain criteria. So the take home is going to be combined for last week and today. It's just one notebook. Yeah.
Okay.
Yeah. We'll post that tomorrow, and we'll give you a longer sort of timeline so that you can work on it. So can I get a thumbs up if today's class seemed useful for you to think like a data scientist? Okay, perfect. I see a good number of thumbs up. I think that is actually encouraging, because tomorrow you are going to be practicing data science in no time. And if this is your very first introduction to data science, I would rather make sure that you understand the ethics better than just learning code and practicing something without an understanding of implication, right? So that is very important. So what we can do is I will continue in the meeting to answer any other questions related to data science, not just ethics of data science. If you have any questions, feel free to post it on the chat or unmute and ask it. If you don't, we can then end up the session by 4:30.